Paul. Ladies and gentlemen, tomorrow night on this television program, actor Danny Aiello will be here, comedian Will Durst, and 85-year-old karate expert Lucille Thompson. Also, viewer mail. My next guest has been with us many times before and is always very entertaining and informative. Well, the pressure's on this guy now, isn't it? He is a professor of physics at NYU, New York University, and tonight will teach us how to have fun with gravity. Please welcome the distinguished Dr. Richard Brandt. Hi, Dr. Brandt. How are you?
Good to be back.
Good to see you, sir. Okay. Nice to see you. Thank you for coming back. As always, you've brought a lot of interesting devices and so forth. Just begin and with your little presentation.
Okay.
I'll be here if you need me.
I'll need you constantly.
Okay.
We'll have fun with gravity.
Fun with gravity.
Now, gravity, you know, is the force that attracts all objects together. I'm going to be careful of my grammar today. Now, gravity is a very weak force. It's actually the weakest known force, but we have a big object on hand, namely the Earth underneath
Now, how
us.
exactly does that work? The Earth attracts everything in its atmosphere to it, right?
It attracts everything in the universe to it, but the further away you are, the weaker.
Yeah. Now, what about two bottles of soda? Would they be attracted to one another?
They attract to one another, and in fact, they've been measured, that force, but it's very, very
Now, how can you measure that force?
Well, you have to get a very, very accurate balance and do it that way. EFVIS, the Hungarian physicist, first did such measurements. Well, there's a lot of...
What was the man's name?
E-O-T, something like that, with dots over the O's. It's complicated.
Pretty certain he's making this up.
No. Famous Hungarian physicist.
Okay. All right. So we know that it is a force. It can be measured.
That's true.
All right. Let's go.
And we'll have fun with it. Now, to begin with...
Well, we'll be the judge of that.
We have to have fun. That's why I'm here. Watch this. Now, if I roll it down one side, it goes up the other side. This illustrates conservation of gravitational energy, potential energy going to kinetic and back to potential again. Now, actually, we'll see a much more dramatic illustration of this a little later. That was it. You know...
I was wrong. We are having fun.
Right. Everything isn't going to be this good. I mean,
let me ask you a question.
Yes.
Now, explain inertia. Is the principle of inertia here in effect anywhere?
No. But, you know...
Let me ask you something else.
This print...
You ever seen one of these?
Why do you want me here if you've got that? Let's move on.
No, I have a question about inertia. The
Right.
tendency of a body at rest to remain at rest, or the tendency of a body in motion, which I guess this is what this is.
Yes.
Now, didn't we see some inertia there?
You see, Einstein's principle of equivalence states that inertial mass that you're talking about is the same as gravitational mass, which I'm talking about.
Right.
That's one of the cornerstones of general relativity, and it equates these two concepts, which are intrinsic.
Let's move on. Let's move on.
All right, now let one ball fall into the pile.
This we've all seen. We've seen a lot of these lovely gift items for...
That, again, is gravitational energy conservation. For example, if two balls come in, two go out. 3, 3.
Now, how do the balls know?
Because they went to NYU. I don't know.
Why do we get two to pop off when it could have been...
That's energy conservation and momentum conservation. It couldn't be any other way.
Or inertia. There's some inertia there.
Yeah, by Einstein.
Yeah, all right.
You know, sometimes gravity can be very subtle, and it doesn't do what you think it's going to do. For example, if I take this thing here and put it at the top of this plane, you'd think it would roll down.
Looks like it would go right down on the little...
But it doesn't. It just stays there. Instead, if we put it at the bottom, it rolls up. Very subtle. You know why?
You know, I think Richard Rothman might be able to use you.
I filled out an application form back then.
Well, I know exactly why. Because it's partly an optical illusion. Because of the conical shape of this, it's actually rolling downhill because of the inverse gradient of the cone.
Now, your writers told you that. You didn't know that. Okay. Even though gravity is weak, it still can have a big effect because it's proportional to the mass.
Okay.
Why you're laughing?
Nothing. You mentioned gravity being weak and so on and so forth. Let's go on with it.
Right. Here we have a 30-pound steel ball.
We're learning an awful lot about gravity, aren't we, Paul? All right.
And we'll see how strong gravity could be with a mass this heavy.
Well, 30-pound ball.
Yeah. we're just going to let gravity pull it down and hit objects placed on here.
Oh, do you need some objects?
Yeah. Do you have an object?
Well, I guess we'll start with the fruit
watermelon?
first.
Yeah.
Okay,
right.
go ahead.
You can
Put that up there. Do I do this, Richard?
I think I'll do it. You'll be in this later.
Yeah, why should I get to have any fun?
David, this will be you.
Okay.
That, I better do this. I've been practicing.
All right, go right ahead.
Let's just make sure it's...
How are we doing on time?
Okay, looks fine.
1 minute, Dr. Brandt.
Oh, easy, easy. Okay, so watch gravity.
Would you like a drum roll? How about a drum roll?
Oh, yeah, we need a drum roll. Ready?
Okay. Okay, we got to move on?
Okay.
Let's go to the final one.
All right, the final one is you. We get rid of this and drop the shelf. I move it back. You stand there. We're going to illustrate your faith in gravitational energy conservation.
Now, where do I stand, Dr.
Well, you're
Brandt?
supposed to put your back against
Yeah,
this.
let me lean right up against this.
Right,
no problem.
yeah. Right. Now, keep your head in that space and don't let it move. Now, if you hold this up to your nose, don't let it go. Just hold it up to your nose.
This is something I've done. I can't hold it, period.
All right, now put your head against the back so it doesn't move. Now hold it right up to your nose. Now let it go back. Drum roll.
Now wait a minute.
Now
Let it go where?
swing. It's going to swing back and then return to your face, but it won't hit your nose because it can't go any higher. That's energy conservation. Drum roll. Okay. Don't let it touch you. Okay, let it go. Now don't move. Keep your face down there. Don't move. Don't move. Okay.
Well. Oh. The amazing Dr. Brandt, ladies and gentlemen. Very nice. Thank you, sir.
Fun. Okay.
We're going to go away. We'll be back with